Hello and welcome to 4-2. We're talking today about the unit circle. Now the unit circle, we've talked about it in class. I have put a blank one here in your notes just for you to practice writing down the values. So pause the video and write them down. The unit circle, I've included here both degrees and radians and the x and y coordinates for it. The unit circle is so important because for these, the most common trig angles that we deal with that are based on the 30, 60, 90 and 45, 45, 90 relationships in each quadrant, they provide us with a crucial key to solving problems. The definition of our trig functions, we can state that the sine of any angle is the y value in the unit circle, and the cosine is the x value. And the tangent is the y value over the x value. The cosecant, secant, and cotangent are reciprocals of those angles, as we talked about in 4-3. So as a result, the cosecant of the angle t will be 1 over y, where y does not equal 0. The secant of t will be 1 over x, where x does not equal 0. And the cotangent of t will be x over y, where y does not equal 0. Now, what we mean by x and y not equaling 0, is basically on your unit circle at 0, pi over 2, pi, and 3 pi over 2, or in degree format, 0, 90, 180, and 270, that each of those right there will possibly have an undefined value. So for example, if the tangent of an angle is y over x, where x does not equal 0, well, x equals 0 at 90 and 270. So thus there is not a tangent, it's just undefined at that angle. The cosecant of t is equal to 1 over y, where y does not equal 0. So where does y equal 0 at? At 0 and 180, or 0 and pi in terms of radians. And so you would not have a cosecant there, and so on. These 6 trig functions give us the keys to solving these identities right here, well, these definitions give us the keys to solving problems based on the unit circle. So, evaluate the 6 trig functions at each real number. So, at pi over 6. Well, pi over 6, if I go to my unit circle, I put one over here on the side, pi over 6 is this one right here. So, the coordinates are square root of 3 over 2 and 1 over 2. So, my trig functions, the sine is simply the y value, so it's 1/2. The cosine is the x value, so it's square root of 3 over 2. The tangent will be the sine over the cosine, the y over the x, so 1/2 over square root of 3 over 2, which gives me 1 over the square root of 3, which is square root of 3 over 3. The cosecant gives me 1 over y, so it is the reciprocal of the sine. So instead of 1 over 2, it's 2 over 1. The secant will be 1 over x. So 2 over the square root of 3, or 2 square root of 3 over 3, when we rationalize it. And the cotangent will be the square root of 3 over 2 over 1/2, which is square root of 3. So all I do is I identify my xy coordinate, that's step 1, and then step 2 are these relationships. And then step 3 is the simplification. Okay, let's look at 5 pi over 4. Well, 5 pi over 4, if I go over here to my unit circle, 5 pi over 4 corresponds with negative square root of 2 over 2 and negative square root of 2 over 2. Step 1, I identify my point. Step 2, I identify these relationships. So the sine of 5 pi over 4, the y value. The cosine, the x value. The tangent, y divided by x. The cosecant, 1 divided by y, or the reciprocal of the y value. The secant, the reciprocal of the cosine. And the cotangent, you could put it as the cosecant over the secant, or you could put it as the reciprocal of the tangent. So my y value and x value were both square root of 2 over 2. So the tangent, because they're the same, it's 1. Well, the reciprocal of 1 is 1, so that's the cotangent. And then the cosecant and the secant are each negative 2 over the square root of 2 respectively. And when you rationalize your denominator, you get negative square root of 2. Okay, let's see for the value t equals 0. Well, when I go to 0, I get the point 1 comma 0. Step 1, I identified my point. So the y value is 0, the x value is 1. The tangent, y over x, 0 over 1 is 0. The cosecant is undefined. Why? Because 1 over 0 does not exist. The secant is simply the reciprocal, or 1 over 1. It's the reciprocal of the cosine, which is just 1. And the cotangent is undefined. Why? Because you have 1 over 0 once again. For D, step 1, find the point. Well, for pi, you look at my unit circle. At pi radian, the point is negative 1 comma 0. So the sine will be the y value, which is 0. The cosine will be the x value, which is negative 1. The tangent will be y over x, which is 0. The cosecant, once again, undefined, because I have negative 1 over 0. The secant will be 1 over negative 1, which is negative 1. And the cotangent is negative 1 over 0, which is undefined. So as you can see, the unit circle is like a cheat sheet of brilliant mathematical beauty. It allows me to take a snapshot of the most common trig angles that I deal with in both radians and degrees, and to say, okay, I've got an x and a y coordinate, and now everything I do corresponds to that. It's so beautiful. So beautiful. So, evaluate the 6 trig functions of negative pi over 3. Okay, well I go negative pi over 3. So pi over 3 this way was 60 degrees. So now I'm going to go back 60 degrees, and it's 5 pi over 3, which is 1/2 comma negative square root of 3 over 2. Remember, we would call those the coterminal angle. So my x was 1/2, and my y was negative square root of 3 over 2. So for my y value, my sine is simply my y value. My cosine is my x value. The tangent is y over x. The cosecant is 1 over y, the reciprocal of the sine. The secant is the reciprocal of the x, and the cotangent is the reciprocal of the tangent, being x over y. So the sine is y, so that's negative square root of 3 over 2. The cosine is 1/2, so that's x. The tangent is negative square root of 3 over 2 over 1/2, which is negative square root of 3. The cosecant will be the reciprocal of the sine, so it's negative 2 over the square root of 3, rationalized to get negative 2 square root of 3 over 3. The secant will be the reciprocal of the cosine. Instead of 1 over 2, it is 2 over 1. And then the cotangent will be negative 1 over the square root of 3, which rationalizes to negative square root of 3 over 3. Next, I'd like to talk to you about the domain and the period of sine and cosine. Let's talk about the domain real quick for each of these functions. And something you will have noticed when you built your trig table is that your sine is always between -1 and 1, and the cosine is always between -1 and 1. Now, this is only true for sine and cosine. What is key about this is that no matter what the angle, when I find sine or cosine, I always, always, always get some number that is either greater than or equal to -1 or less than or equal to 1. And the same thing with the cosine. What we're going to talk about now is the concept of a periodic function. We dealt with this when we talked about angles that are greater than 360, and that you subtract away 360 from them to find the angle that they are. So if I gave you 390 degrees, you subtract it from 360 to get 30 degrees. And then you'd find the trig function of 30 degrees. So a periodic function exists if there is a positive real number c such that f of t plus c equals t, being that t is in the domain of f, and the smallest number c for which f is a period of its periodic is called f. So for example, using the period to evaluate sine and cosine, let's say that I had 13 pi over 6. Well, 13 pi over 6 is greater than 2 pi. If I were to put it this would become 390 degrees. Because it is equal to 360, which is my entire period, or 2 pi, which is my entire period, plus pi over 6, you can state that it is simply equal to, that the sine of 13 pi over 6 is equal to the sine of pi over 6, because it is 1/2. If I were to graph the angle 13 pi over 6, it would go around once and then up by 30 degrees. So because of that, I can subtract 360 from it, or 2 pi from it, depending on if it's in degree or radians, and I can find that, okay, well, on my regular unit circle, it corresponds to pi over 6. That's 30 degrees. The sine of pi over 6 is the y value, and the y value for 30 degrees is 1/2. For negative 7 pi over 2, okay, for negative 7 pi over 2, if I were to convert that into degrees, let's convert it real quick into degrees. 7 pi over 2 times 180 over pi. So now you have negative 630. You have negative 630 degrees. Okay, well, you consider the fact that basically, in this case, what you have is you have something that's going around it multiple times. So when you subtract away your excess turns around the unit circle, you are left with pi over 2. So I would find the cosine of pi over 2, which is 0. Let's say that I have, and finally in this example, let's say that I have some calculator functions. Well, you can plug it into a calculator. One key thing that you will need to change and to make sure is set properly when you're in this chapter and in the chapters to come is what's called the mode. The mode tells it whether or not you're dealing with radians or you're dealing with degrees. If I'm dealing with radians, then I'm going to put the sine of the angle in for radians. So 2 pi over 3 is the same thing as 120 degrees. If I type in sine 2 pi over 3, I need my mode to be radian. If I type in sine of 60 or sine of 120, I need it to be degrees. You'll get the same answer either which way, but you just want to make sure that your mode is correct. But this shows you the calculator keystrokes. Our calculator will have one more button that you'll put. and that's the trig button. You'll push the trig button and then just type it in and press enter, and it gets you your answer. Okay? That is useful for when you're dealing with something that it's not necessarily on the unit circle. And that concludes today's lesson.